Welcome to this CTO Focus. Today we are going to have a short session on code quality and technical debt. When it comes to these terms, people usually have a lot of questions. What is quality? Why do we use the word debt? Can we measure tech quality? What can I do to write better code? How can this even work? How is this documented? What does this code mean? And of course, my preferred one, why am I debugging this again? Haven't I fixed that before? So let's try to define quality first. Quality is the standard of something as measured against other things of a similar kind. So you can only talk about quality given different options within a certain context or system. And it's the degree of excellence of something. And quality is also something that is valuable to someone in a given context. So we need to identify these persons that think that actually our work is of good quality. When you have multiple stakeholders, you might have multiple goals, right, in their own minds. So how do we align them in order to produce what is expected? What is the good quality that we are trying to reach? How do we align? With feedback. With even more feedback. And finally, with feedback. So it's all about the feedback loop. We need to make sure that people align at every step of our journey in order to produce what they all have in mind. So you can have release plans, of course, but in order to have more feedback and more often, you need to optimize this feedback loop. And at the very end of it, what we are trying to achieve is to have pair programming, meaning that whenever we develop something, we have almost real-time feedback on what we are coding. So the practices around aiming towards better quality, we have them here. First is the feedback loop with pair programming. We've already covered that. But then we got code design. We need to make sure that we respect some of the best practices out there, like keeping it stupidly simple. You ain't gonna need it, meaning that we should not develop things that are not gonna be used. And dry, don't repeat yourself. Make sure that you optimize things so that you can reuse what you've already done. Then you got iterative methods. One of them is test-driven development. And of course, it comes with pair with refactoring. Whenever you develop something, you test it after you have tested it first, it failed, you develop it, and then you need to refactor afterwards to make it even better. Then you got monitoring, and that's one of the key points about quality. We need to know what's out there, we need to know what we have deployed, and we need to calculate what we call technical debt. What is technical debt? Technical debt was coined by Edward Cunningham. It's defined by three principles. The first one is the only program with no debt at all is an empty program. It's the blank slate. When you start introducing things, then you have debt. And debt is paid only with refactoring, or it's completely erased if you start from scratch again. And while the debt is not paid, interest accumulates, meaning that the later the debt is paid, the more it will cost. So permanent refactoring is the heart of debt control. Even if you do test-driven development, you need to refactor afterwards, and you need to make sure that it still passes all the tests. Right? A little bit more about technical debt. Accumulation of debt can have several causes, and we need to look at these causes to work on them in order to make sure that the debt is controlled. You can have bad understanding of the business needs. You can also have procrastination, meaning that we'll improve the system tomorrow. You can have pressure from the business, so you need to make sure that to ship early, and that's usually at the cost of quality. You also have ongoing bad development practices, and you never take time to look at them. You also have no continuous refactoring. Remember, even if you have tests, if you never refactor, you never work on the overall quality of your design. And of course, the absence of proof of validation. If you have no tests at all, then what can you monitor? So technical debt appears as soon as you write code, of course, but the main goal is to not erase it, is to control it, because we can live with it. Martin Fowler described our behaviors, all right? When we do design and when we are taking care of quality, what are our behaviors? So you can be deliberately reckless. We don't have time for design, so I'm just gonna go for it. Inadvertently reckless. You don't even know what layering is, and that's actually pretty bad, all right? You can also be prudent, at the top right, okay, we must ship now and deal with the consequences, but you are deliberately prudent in that aspect. You know what you're doing, but you can be inadvertently prudent. Now we know how we should have done it, meaning that you have done something and you try to learn from it afterwards. So when we deal with quality, how do we introduce it? We need to make sure that we have the correct balance, because in a project, usually we have quality, speed, and cost. And we can only choose two of those in order to make things work. We can have a project that is of good quality and very high speed of delivery, but it will cost a lot. Or we can have something that is quite cheap and delivered fast, but it will be usually at the expense of quality. And finally, we can have something that is cheap and of very good quality, but it won't be delivered fast. So how do we influence these elements? How do we make sure that we have better quality and things like that? We have multiple leverage. One of them is to work on the scope. If you want better quality, of course, you need to work on the scope, because then you will reduce maybe the time it will take to create the design that you want, and maybe you will also influence the cost. You can also work alongside the stakeholders in order to influence that, and then maybe delay the delivery. You can also work directly with the customers, because they want the features fast, and you have to see how you can deliver maybe in another way of streamlining features to them. And of course, you can work on the resources, right? Maybe with someone that is better qualified in order to deliver the feature, you will have better quality. And then you can work on the risks, right? So if you assess the risk correctly, if you can manage to show that if you don't have the quality, then it will the cost will be even higher. Maybe you can just go towards quality even more. So how do we measure technical debt now? We have 4 categories to measure that. We have maintainability, dependability, efficiency, and usability. Maintainability, it's all about the availability of our system, the modularity of it. If we can still remove something and it will still work. Then we got dependability. Dependability is, how is my system available? How is it reliable? If I send it a request, will it give me always the same kind of responses given a certain context? And of course, security. Is it secure enough? Can I depend on it? And then you got efficiency. It's all about the performance, the time that the time of processing of our system, and also the size of it when we deploy it, and of course its resilience. When we overload it, how does it react? And finally, the usability. Usability is all about the clear interfaces and the clear documentation. So now we are going to talk how to measure technical debt, and that's with quality gates. Quality gates, usually, they are here most of the time in CI/CD pipelines, and they will tell you whether or not your code is of good quality and that can actually be shipped to production. It's based on multiple parameters. One of them is the number of tests that you have passed, and also the coverage of these tests. You need also to look at static code analysis if it respects some rules in coding, layering, and security, and can detect code smells as well. So in a CI/CD pipeline, of course, it will indicate if it's acceptable for you, the current technical debt that your code has incurred. Let's take Sonar as an example of technical debt. Sonar has a built-in SQALE rating. SQALE stands for Software Quality Assessment based on lifecycle expectations. If you say that whatever you ship should have at least a B rating or an A rating, it's up to you, and you can use Sonar as the gatekeeper in order to ship your code to production. Also, you can define your rules in there. What is quality is actually very subjective. It depends on the teams, right? Of course, Sonar will help you and will guide you inside those rules, but you are the one that will have to tailor that to your current context. Then we have different tools in order to address technical debt. Okay, we are not naked. We have multiple means in order to control it. One of them is to understand what we are doing. And of course, is to choose the right paradigms when we program. It's not the same when you use functional programming, reactive programming, object-oriented programming. Okay, they are meant to solve different kinds of things, of issues. Then we got software design patterns. Usually we have common issues that we know how to solve with patterns, and it would be a shame if we do not use them. Then architectural patterns. So when we have big issues and structural issues, rationalization issues, maybe we should look at those. And there are answers out there to be applied to our current problems so that other people can understand it faster as well. And of course, we can delve into other methodologies such as behavior-driven development, domain-driven design, and test-driven development. Let me talk just a bit about domain-driven design. Domain-driven design is a method and it's an approach in order to make sure that we have an alignment with the business needs and with the technological implementation. So on that aspect, I think it's very good in order to reduce technical debt. How do I get started now with technical debts? Of course, a good way to always start is to plan, do, check, act, and to repeat the cycle. So first, you need to define goals clearly. What is quality for you? How do we sync up on a clear vision of what we need to achieve? Then we follow the good practices. We reuse all the tools that we have at our disposition. Then we monitor the debt. We have applied all the good practices. We still see that there is an incurred debt because it's never a blank slate, what we produce. And we look at it. And of course, we react, we refactor, or redesign, and then we repeat the cycle. So I hope it was helpful for you, and I hope we can share more in the future together. Thank you very much.